This is Jeff. Welcome to the Introduction to Visual Models. This is part 2 in the series, Operations with Arrays. If you missed the first episode on representing whole numbers with visual models, you might want to check that out. You can find me online on Twitter at JeffEdTech or on my website, jeffhelpsyou.com. Here's a quick recap from last video. Why do we do visual models? They help us better understand the meaning behind the numbers we're working with. We could use it as a communication tool to demonstrate our understanding, and they can even be used to calculate or problem solve. In some cases, replacing stacking or traditional algorithms entirely. Here's some best practices I've found for making visual models. Separated into 3 steps. If we're adding 2 numbers, we have a starting value. Right? 3 plus 2 equals 5. Show that you start with 3. Show that you're adding something in. Show that you have a final answer. This goes for any operation. And make sure you actually show the operation. Don't just use an addition or a multiplication symbol. That's not what visual models are all about. Color coding your steps can make it even more clear. And label the steps so that we know what did you start with, what did you do to the number, and where did you finish. When you're done, pretend that you didn't write this visual model and take a look at it. Would you be able to understand what it meant? If so, then it's probably a great visual model. So let's start with addition. It's our most common and basic operation. As you can see, I started with 4 blue squares, and I'm going to label that as 4 in the same color that I started with. Next, let's make a few more squares. And notice I duplicate these, so they're all the same size. I know that we're dealing with the same thing. And I'm just going to change the color. To yellow. And then I will label in yellow that we're adding 3. And then finally, let's just circle it all in green so that I know that my total is 7. So now we've started with a value of 4, we've shown that we're adding 3, and we finished with a value of 7. Our next operation is subtraction, and pretty much just as simple. It's going the other way of addition. Again, I'll label that I'm starting with a value of 4. Okay, this time, instead of adding extra squares, let's say I take away 2 squares by putting an X through them, and then I'll label that that was minus 2 because I took away 2, and then again, circle my final answer and label that it's 2. So now I have a visual representation that 4 minus 2 is 2. Now on to multiplication. A little bit more complex than the other 2, but multiplication is just repeated addition, so I'm going to use similar principles. Okay, I'll select all 4 of my boxes here, and I'll duplicate them twice. So now I have 4 times 3. Now it's going to be a little bit different because I'm not actually adding anything on. So what I'm going to do is I'll show that I have 4 going this way, and in another color, in yellow, I'll show that I have 3 going this way, and again I can circle the whole thing and show that my final value of 4 times 3 equals 12. Maybe put a little X for times 3 over here so that we see that's what we're doing. Okay, and this is a great example of an array where we have 4 boxes in one line, we have 3 lines down. It's a great preparation for thinking about area as well. And finally, our 4th basic operation is division. So you can see again, we've started with some blue boxes, and we have 12 blue boxes to start. So let's label the blue as 12. Now some of you may notice this looks a lot like multiplication. We have 4 boxes and in each row, and we have 3 rows. And now this makes a lot of sense if you think about the fact that division and multiplication are opposites. So we're going to start with 12 here, and instead of copying the groups, we're going to split them into 3 equal groups. So 1 group, 2 groups, 3 groups. And I'll label this as divided by 3, and then we can just label that our final answer is 4, to note that in each group there are 4 boxes when we divide 12 by 3. Now some of you might be thinking, well, that's not the only meaning of 12 divided by 3, and I'm glad that you're thinking that way, or that you're thinking about this can mean something else. Division can be splitting into a set number of groups, like taking 12 things and splitting them into 3 groups, or it can mean splitting them into groups of a certain size. And this is a really helpful concept as you get into word problems, and it's just really good to know that there are multiple things. So this could also be a representation of 12 divided by 4. In this case, instead of splitting into 3 groups, we're splitting into groups of 4. So if I label this as 12 divided by 4, then I'm going to have my final answer measure how many groups are there altogether. So if we break 12 into 3 groups, each group has 4 in it. Or if we break 12 into groups of 4, there are 3 groups altogether. So either of those would be a correct meaning, and it shows another reason why we need to label our visual models. Well, I hope this has been a helpful guide to working with operations and visual models. In future episodes, we'll look at visual models with fractions and decimals, and then again doing some of the same operations with fractions and decimals using visual models. Thanks for tuning in.